to Packet Tracer 4.7.1, Physical Layer Exploration, Physical Mode. In this exercise, we have two objectives: examine local IP addressing information and trace the path between source and destination. So the background: in this Packet Tracer physical mode activity, you will trace the physical path of IP packets from a home in Monterey, California, to a web server at the University of Hawaii on the island of Oahu. You will do this packet tracer on your computer. So in this packet tracer simulation, a student lives in Monterey, California, and regularly uses a web browser to access the University of Hawaii's website. That website is www.hawaii.edu. As she views the information downloaded from the web server to her home computer, she becomes curious about how the IP packets traveled between Monterey and Hawaii. So what is the path those packets actually take, and how did they travel over the Pacific Ocean? So you're also interested in these questions and will investigate the path from your unique location to the server in Hawaii. So this activity follows the packets between two devices in two specific locations using their specific internet connections. Two other devices in both these same two locations, but using different internet connections, so different ISPs, would likely result in the IP packets taking a much different path. So this activity is only one example of how a variety of internet and network service providers interconnect to create a path between two devices that are communicating using the internet. There are many different possibilities of the path the packets may take, depending on different things like the location of the client computer, the client's ISP, the location of the server computer, the server's ISP, and how the various ISPs and other entities interconnect to form a path between the client and the server. In this activity, you will begin to get an understanding of some of the various entities and organizations involved in making sure IP packets travel successfully between two devices on the internet. You will see how packets between your home computer, known as a client computer, travel to a web server. So there's a note here. It says this activity was created by following an actual connection between a home computer in Monterey, California, to a web server at the University of Hawaii. Now, the terms and devices referred to in this lab may differ from your connection depending on your location and the service providers involved. In addition, the information used in this activity is subject to change depending on the service providers. Some of the information has been simplified to make the information more understandable. Furthermore, all the information in this activity was discovered by the authors using common web research tools. None of the organizations mentioned in this activity were contacted to verify the accuracy. Now, finally, the IP addressing scheme has been altered to avoid using public IP addresses. So those are some things to know about this particular activity as we get started. So here are the requirements. You need a PC with Packet Tracer installed, which we have, and a connection to the internet. Using a mobile device for this activity is not recommended. Okay, it really does take a PC. So in part one, we will examine the IP addressing information in your home network. So your IP address is used to identify your computer when sending and receiving packets. Similar to your home address is being sent, like to send and receive mail. You can use the command ipconfig on Windows and the ifconfig command on a Mac and Linux. Here's a note. This activity opens inside the home network. If you explored other locations, navigate back to the home network. And we are in the home network right now. We're good. So click the home PC. Let's click the home PC. The tower, not the monitor. Okay, the home PC. And then let's see, I wanted to go ahead and put this on top. And then it says, click desktop tab and command prompt. Here's our desktop, here's our command prompt. Okay, so then what we're going to do is we are going to enter the ipconfig command. And this will examine the IP version 4 addressing information for this particular home PC. So here we go, we have our information. And then it tells us here, this is showing us just an example of what this should look like. And that is what ours looks like. It's showing us what the IP version 4 address is, which again is right here, and what our default gateway is. So we've got that. Now the IP version 4 address, which we can see there on the screen, is known as a private IP version 4 address. So most client computers and other devices use a private IP version 4 address. These are devices that don't require another device to access it from the internet. So private IP version 4 addresses are used to conserve the limited number of globally routable public IP version 4 addresses. So again, we want to make sure that our internal devices aren't using up external IP addresses. Now this says to repeat this step on your own device. So go ahead, pull up your command prompt and issue the same command that we just did, ipconfig if you're on a Windows device, or ifconfig if you are on a Linux or Mac. Now, what is the IP version 4 address and default gateway for your device? Just go ahead and make note of that. Now in step 2, what is the IP4 address for my router? So again, this same window, ipconfig or ifconfig if you're on a Mac, shows the IP version 4 address of your local or home router, also known as the default gateway. So your router is, that is. So notice that your local router has the IP version 4 address of, in this particular case, 192.168.0.1. And that's right here on your screen. So they're talking about this particular one. This is the router that connects your local home network to your internet service provider's network and gives you access to the internet. So you may have a different number when you pulled up your command prompt. You may be using a different IP address. There's a note here that you can get the route --n get default command to determine the default gateway on a computer that's using Mac OS or Linux. So, again, write down what is your IP version 4 address for your router. So it's going to be different than what you're seeing here more than likely. And step 3, says, what is my public IP version 4 address? So again, they're telling us that private IP version 4 addresses are not routable on the internet. When IP packets leave the network, they need to have their private IP addresses replaced with a public IP version 4 address. The public IP version 4 address is used by servers or any other destination to send packets back to your client computer. So where does this translation between private and public addressing occur? Well, that happens in your local router. Okay, your local router is doing this translation for you. So how can you find out the public address that your local router substitutes for your private IP version 4 address? So they're asking you on your device, search the internet for what is my IP. Some search engines will tell you your public IP version 4 address without the need to visit another website. In addition, several websites will be listed which will provide this and other information. There's a note here that many ISPs have begun to use IP version 6 addresses. Private addresses are only necessary to conserve the limited number of IP version 4 addresses. Using 2 different addresses and translating between them is not required with IP version 6. So in the packet tracer, we're going to close the command window and click on the web browser. Okay, oops, I didn't mean to close it all out, but there we go. We're going to go to the web browser. So we're on the computer. We went to the web browser. Let's go ahead and give this a shot. So in the URL, we're going to say www.tellmemyip.com. And let's see what comes back. Okay, it says, and then click go. So this may take just a moment. There is a note here that tells us that this website, by the way, is fictitious and it currently only exists in Packet Tracer. So that took a minute to come back. You would have thought it was really going out to a web server somewhere. And in addition to the public IP version 4 address, notice that the website we use provide other information, including the name of our ISP and the geographical location. The ISP information is usually very reliable. However, the geographical information may be city, state, and country, and geolocation, maybe that latitude and longitude, is not always completely accurate. So notice that the website we used shows the city as Pacific Grove, about 5 miles from our home location in Monterey. This information is typically a region that the ISP has used for all customers in that area. So now on your device, do the same thing. Use one of the What is my IP websites that you find and find out what your location is. So again, just pull up a web browser and type in what is my IP, and let's see what kind of search results come back. I'm just going to pick for mine the very top one, and not sharing that on the screen. I don't think you need to necessarily see what my IP address is, but do that on your computer to see. I was curious to see if it told me the correct city, and it did. It identified me in Lexington, and that is where I am, is in Lexington, Virginia. The reason that can be important is I will tell you I had T-Mobile for a while, and when I was using T-Mobile, it came back that I was in a different location, and as a matter of fact, it triggered a security event at work, and I was actually called to see if I was in another state. Not because they cared what state I was actually working in or working from, but because I had never been working from that state before, they wanted to make sure that my account had not been compromised. So as you can see, that can have ramifications for security as well. Let me bring that back on top. I'll click the top button. So you can see here what it's telling us the information is and the location is here. Okay, so now we're going to examine the connections in your network. So what does the connections look like between the device and your router? Is it wired or wireless? And so in this case, I guess I would need to go ahead and close this. So in this case, we want to know wherever the router is that wired or wireless? You may have to use some magnification to check that out and see how things are connected. I'm just looking down here, and to me, it looks like there might be a wire coming over there. Looks like that is probably a wired connection. Now I'm going to use my little magnifying glass up at the top and take a closer look at that. And to me, yes, this looks like that is a wired location over to my router. Now, if I hover over these, it will tell me this is the home router. If I was not sure what something is, which I'm going to look, this is a cable modem. So we have a cable modem, we have a wireless router here, which is the home router. Okay, where is the router? You can go ahead and explore. I won't go through all of these. They're telling you that you can search for YouTube on Tor Home of Network 2020 8-Bit Guy. So, take a look at that. I want you to go through and do these particular steps in step 4. Now, in part 2 of this packet tracer, you're going to use the trace route command that's used for network diagnostics and for displaying the path packets take to a destination. It gathers information about every hop from your device to the destination. Each line in the output designates the IP address of a router used to forward packets from one network to another network. These are known as hops. In Windows, that command is traceroute, spelled T-R-A-C-E-R-T, T-R-A-C-E-R-T, okay? And then whereas in your Mac and Linux operating systems, you're going to use the command traceroute spelled out. So traceroute, all one word. So in this case, we're going to open Windows again, and we're going to issue the traceroute command. So let me just pull this over here, and we're going to go to our command prompt, and let me see what it tells us to specifically do here. So we are, during this part, you'll be investigating the output of 2 trace routes. One will be from the home PC inside Packet Tracer. The other will be from your own personal device. So we're going to go here with step 1. We've opened up our command prompt, and we're going to enter trace route. I'll just do it right over here in the window. Trace route. Let me zoom in a bit so you can see this just a little bit better. I know it's really hard to see my screen when I've got the whole thing on there. So just bear with me. There we go. So we are going to do trace route. And again, I'm on a Windows machine, so I'm going to spell it this way: trace RT space www.hawaii.edu. Okay, that's what our directions just ask us to do. I'm pressing enter, and you can see it is tracing the route from this computer in the simulation to our friends at www.hawaii.edu. So every IP address listed here is a router that this data is going through to get there. So you can see it's not just next door, right? And now your trace is complete. And look how many hops or how many different routers it took to get to www.hawaii.edu. Now go ahead and do the same thing on your computer. Okay, it does tell you here when the output begins to time out, or for the 15th and 16th hop, you can go ahead and just hit Control-C to stop it. Otherwise, the trace route, will continue until it reaches a maximum of 30 hops. So you can go ahead and do that on your home PC as well. So they tell us here that, again, up to 30 hops, or if you're doing this on your own home PC, you may find that it times out well before that 30 hops. And you can just go ahead and do Control-C to get out of that. Now, also, it says the first highlighted entry in the example shows the first hop as 1. Okay, and you can see over here 1, 2, 3. They're numbered at the number of hops that it took to get to where we were going, which was hawaii.edu. The directions also say look closely at the first line of the output. The 3 numbers preceding the IP address are timestamp values, such as 3ms, 4ms, 5ms for the first hop. So those are milliseconds. This is the round trip time between the source device and the router at the IP version 4 address. So traceroute also includes the IP address of the router interface that received the packet from the source of the traceroute, so the client computer. The highlighted entry in the example shows the first router as IP version 4 address 10.0.0.1. Okay, and if we go back up here, that's going to be the example that they have up in the directions. So right here, 10.0.0.1. Some hops may also include domain name information used by the service provider to kind of help document information about the router, such as, and they give you like this very long example here, and that was also highlighted up here in the output. So there we see that there. And we did not see that in our trace route. So just to make that, there we go. We did not see that in our particular trace route in Packet Tracer. Okay, so although the output timed out before reaching the server at hawaii.edu, the prior hops provided enough information to trace the path of our packets. So on your device, again, try tracing the route to other websites, such as maybe www.netacad.com or www.google.com. Some hops will probably time out. Some web servers may not respond to a trace route. That's for security reasons. But go ahead and give that a try. It's always worth taking a look. Now, once you've done that, come on back here, and in step 2, it says investigate the second hop in the trace route output. So go ahead, pause this if you need to, go ahead and do a trace route on your home computer, and then go ahead and hit this play button. Okay, so welcome back, and it says the trace route shows a second hop of, here's our hop number 2, and here's our IP address. The IP packets now leave the home network, and they're sent to the ISP. The 10.120.89.61 is the IP version 4 address of the first router outside the local home network. This router belongs to the ISP. This router is known as the ISP's point of presence, or POP. This is where the ISP provides its customers access to the internet. The physical connection between the end user and the POP is known as the local loop, or sometimes we call that the last mile. So traditionally, the local loop was the telephone line from the customer's prem to local telephone exchange, sometimes referred to as the central office or the CO. And I know right now you're thinking, oh my gosh, all these terms. It's okay, you'll get those. If you haven't already started to get the terms, just read this a couple of times through and you'll start understanding when sometimes people say local loop or last mile or CO or whatever they're saying, you'll understand what that means. Now, the copper twisted pair cables at that time were used to carry analog voice and signaling information. If you've never been inside a CO or central office before, it is pretty amazing. All right, so today the local loop may also include cables to carry digital information, which might be wired or wireless. So in terms of internet connectivity, the local loop connects the customer's prem to the ISP's POP. The local loop may be one of several different types of connections, and there's a whole bunch that they list here, but including things like your cable connection, your DSL, wireless signals, satellite connection, fiber optic, dial-up. I don't know if anybody still has dial-up these days. I wonder if you guys have ever used dial-up. Oh my goodness. That's how I first started using the internet, was dial-up. Okay, now let's come on back over here in Packet Tracer and notice that the home PC on the desk is connected to a home router. However, and that's on the shelf behind the desk, which we kind of discovered a few moments ago. However, the home router is not connected directly to the router at the next hop. Instead, it's connected to a cable modem. This cable modem is not a router, therefore is not reported as a hop in the traceroute output. So now navigate to Monterey. Notice that the next hop is physically linked to Comcast POP building. Okay, so let's see if we can do that. How do we do that? Okay, to get to Monterey, I just need to bring this up here, and I'm going to have to use this button to connect or to go back a level. So here we are. We are now, here's Monterey, and let's see what it says. Navigate to Monterey. Notice that the next hop is physically linked to the Comcast POP. Okay, we have a physical connection there. Click the Comcast POP. Okay, and now we're inside the Comcast point of presence. A POP is physically located in a data center. A data center is a physical facility that organizations use to house their critical equipment, applications, and data. The key components of a data center design include routers, switches, firewalls, storage systems, and servers. Although the Comcast POP would typically be a data center in the real world, in Packet Tracer, it's only storing the equipment necessary for this activity. So in the rack, you will see several devices, including a device simulating a cable modem termination system that's called a CMTS, the Comcast POP Monterey router, a multi-layer switch, and 2 servers. I believe if we hover over them, they tell us what they are. Yes, they do. So if you want to know what each item is, just hover right over those items. Now, what they want you to do next is investigate the physical connections between the devices. One interface of the Comcast CMTS is linked directly to the cable modem in the home network. The other interface is connected to the next hop router. Comcast POP Monterey, which is racked directly below it, and the Comcast POP Monterey's second interface links out to the next hop, which you will investigate in the next step. The third interface is connected to the switch, which is then connected to the 2 servers. The DNS server is translating that www.hawaii.edu and the tellmemyip.com to their respective IP version 4 addresses. The web server is serving the website www.tellmemyip.com. So I know that's a lot to take in, but wow, is that not incredible? Think about that. That is a really incredible that these items are so interconnected and that they work and serve, us what we need that quickly. So go ahead, you do step C by checking, taking a look at those physical connections. And then step D in your own network, what is the technology for your local loop that you're using? Is it cable, DSL, satellite, cellular? If it's a wired connection, can you find out where that cable is leaving your home? Do you know where it goes? Is it underground? Is it on a telephone pole? That type of thing. The second hop in your traceroute command on your device is typically your ISP's POP. So what is the address of that? So and then in step 3 of this, some of which I'm just going to let you do some of this on your own, but in step 3, who owns the POP for the second router in your traceroute output? You can search the internet for IP lookup, which will result in a list of websites that will give you information about an IP address. So go ahead and fill out this table below and see what you can discover. Now go ahead and I'm gonna leave you here on this particular journey because now I think I've gotten you to a point where you can finish out this lab on your own, doing steps 4 and 5 and 6 And just going through each item. I think you probably feel comfortable navigating through the rest of the lab. If for some reason you run into a point of concern, please let me know. Just give me a shout out on that Canvas inbox. It is worth noting that this particular lab does not have any configuration items that you need to do. So therefore, check results, there won't be anything at all on the assessment tab. But go ahead and just answer the questions for this lab, and then you'll answer some of those questions in Canvas as well. All right, so if you need any help, please let me know. Otherwise, I'll see you in the next video.